Thank you. Hi, everyone. Thank you for coming. I know this room is a bit massive, but the presentation contains some slides that have source code and images of small visual glitches. So move close to the screen if you can. In any case, then let's start with a self-introduction. So I'm Lukas. I work at DroidKaigi as an Android engineer in the mobile architects team. For those people from outside of Japan, DroidKaigi is, I think, the biggest C2C marketplace in Japan. We're a team of about 40 Android engineers working on the marketplace and some associated payment system called MirPay. In any case, today I'm going to talk to you about our experience using screenshot testing. I thought to understand the problem that this is trying to solve. It might make sense to take a step back and explain how I personally got interested in this topic. So when I started my career, I actually spent 3 years working on non-UI code. So our product had a lot of users, so naturally to keep the quality of our product high, we had very high test coverage, a lot of unit tests, some integration tests, and a few end-to-end tests. Eventually, though, I got interested in becoming an Android developer and started working in a feature team where I would also have to write UI code. So in that team, we also had really good tests for business logic, but I was surprised that there were no tests for UI rendering at all. Instead, and I think everyone might be familiar with this, every time I made a UI change, I was essentially taught to post screenshots on the PR with the before and after state. It felt very brittle and very prone to errors, especially considering that we shipped to a couple 100 million users, and there was no no additional step between me merging the PR and it going out to users. What made things worse was that the product I worked on was also released in many countries and on many different types of devices. So to serve those customers well, we had some density-specific UI code. So every time we made a UI change, we also had to test using all those different densities. That essentially meant spinning up a bunch of emulators, taking screenshots before and after the change, just to create that PR description. So given build times of large apps, I often spend something 30 to 40 minutes just doing that, even though the code change by itself would just take maybe 5 minutes. So ironically, when I took this screenshot, I didn't even notice that, but my colleague pointed this out a couple of days ago. I really only wanted to illustrate the point of taking lots of screenshots manually, but you can also see that the rendering on the left side is actually, the text is cut off. So it can't be read fully. So I think if we had some automated tests for this, I'm sure this would have been fixed already. In any case, after some time, I quit my old job and I joined DroidKaigi, and I was hired to work on their design system. If you never worked with the design system before, you can essentially think of it as a set of shared UI components and design guidelines that help designers and engineers create screens with a consistent look and feel within one application. So when I joined DroidKaigi, I was tasked to look after the component library that they had already built over the last 2 years. The components they had built were already quite complex, supported a lot of optional parameters, and in the code there was already a lot of branching. But again, we really didn't have any automated tests. Instead, we had these kind of test cases that you can see on the screen. Essentially, we had a separate app where we would kind of lay out all sorts of, one component with all sorts of different sets of parameters. Then we still took screenshots manually and had to do the manual comparison. On top of that, if we changed one component, we also wouldn't really know how it looked on the usage side. Sometimes when there's not so many usages, maybe you can check manually, but if you imagine in your design system you also have something like a button and you change the appearance slightly, you don't actually know how it looks everywhere else in the app. Aside from all the time spent creating screenshots manually, I also want to stress that this comparison manually is really not optimal. It's really work that depends on the reviewer themselves and most importantly their eyesight. It's very easy to miss some pixels here and there and introduce small glitches to your app. For example, here I introduced some small glitch in this component. I'm not sure, I think I can't even see it here because it's very bright, the display. But yeah, on the small screen it's even less possible. But yeah, I really need to take out the magnifying glass because it's impossible to spot. Here, I even changed the background to make it obvious. But you can see that, like in the corner there, we're leaking the background of the component outside of its border. Like this essentially happens if you have a component with a round border, but you don't clip the background using the same shape. It's something that can happen really easily. Essentially, you can switch the order of like compose modifiers by accident, and then you end up with something like that. So while on Android we had to do all this like manual testing, the situation was very different for our iOS developers. They had a suite of visual regression tests that will not just like automate taking the screenshots themselves, but also assist them using like image diffing tools to find visual differences. They essentially aim to rigorously test all parameters on design system components, but also then check the integration of these components into each screen. So it kind of seemed like the ideal situation to me. If you make a UI change, like you should be able to figure out, to kind of semi-automatically verify if it works. So at the time when I joined DroidKaigi, we really wanted to catch up and like figure this out on the Android side as well. So essentially in this talk, I want to like chronologically go through how we adopted screenshot testing at DroidKaigi. First of all, we kind of need to have some general idea on how to achieve this. Like, what exactly are we aiming for? What scale do we expect? Like, what framework would be a good fit for these like goals and constraints? We'll then talk about how to set up the actual CI/CD pipeline that's necessary for these screenshot tests to run as a pre-merge workflow for each pull request. And then when that is done, we can like write some test cases and use screenshot tests to verify our UI code. And finally, I want to talk a little bit about our current state of adoption and some things that we're still missing. So when thinking about this, the first thing I wanted to do is clarify that unlike traditional like unit integration end-to-end tests, we don't aim to test like the core business logic of the application, but just kind of how the UI renders on screen. This can kind of be thought of as both like testing small parts of the UI, like these design system components very rigorously. It's kind of similar to how you maybe write unit tests for your business logic classes. Here you would kind of aim for like full branch coverage. In addition, we want to test this combination of UI elements on each screen, so kind of more like an integration test. So to be able to pick a framework to achieve that, we thought maybe we should first understand what kind of scale we can expect and like specifically like how many tests we approximately are going to have. Yeah, to illustrate what I just explained, I drew this like testing pyramid. You can see that we want to test like on the bottom of the pyramid, so we already expect it to be a lot of them. Yeah, we don't really need tests end-to-end, I think. Those should really just be reserved for testing the main logic of your application because of the drawbacks of end-to-end tests. But yeah, when I first looked at the problem, I made some rough estimates of how many test cases the design system module alone would have. I thought, well, we have roughly 60 components, and each of them would have maybe 10 test cases each, so there would be 600. At that stage, I was also thinking that it would be nice to not just generate one screenshot per test case, but maybe also take one screenshot in dark mode and one in light mode, because at the time we were like working on our dark mode support. And maybe eventually we could extend that to like test different screen densities. given that we'd like easily have more than 1,000 screenshots in the design system module alone. So like overall, I would expect like several thousand screenshots. So like, given that scale, the performance of the testing frameworks really becomes an important factor. When comparing screenshot tests with just like classic unit integration end-to-end tests, we also notice some differences. Like in these traditional tests, we can always break them down into these given, when, then parts, like some precondition, an action that moves the state along typically, and some post-condition that we want to verify. Like the post-condition can always be automatically checked in this case. Like essentially, these are your assert statements at the end. For screenshot tests, that's not really the case. We really just want to render our UI code given some data and then check if it renders correctly. Like there's no like action that moves some state along typically. But then also, how do we check if the UI renders correctly? There's no like automatic verification that tells us, oh, this UI looks good now. It's always up to the viewer. And typically it's up to somewhat of a discussion between designers and developers where they need some sort of agreement on if it looks correct. So imagine now if you have a lot of test cases, checking the result of all these test cases for every PR is like highly impractical. It's just like too many. It takes too much time. So, and on top of that, for most code changes, only really a small subset of images would actually change. So really, instead of this kind of automatic verification that we have with traditional tests, we really want to generate a report of visual differences that our code change produces. So essentially, this means that this problem can be broken down into two parts. First of all, you have these test cases that generate screenshots. And then you want to generate a report of visual differences. These can essentially be solved by two different frameworks. So in this talk, we'll treat them separately. So during the evaluation phase, we looked at some frameworks that can tackle this first part of the problem. We essentially looked at two categories of frameworks. One is, I just call it like JVM-based screenshot generation. I'm not sure if that's the correct name, actually. What I mean by that is essentially tests that run locally on your computer, like unit tests or like traditional integration tests. Yeah, there's no emulator or device needed here. The most famous example is a framework called paparazzi. And then there's also frameworks that actually run on an emulator or device to generate screenshots. In this case, we looked at a framework called Shot. So let's take a look at their high-level properties. So since like JVM-based test cases, they will run on your own computer, they're really easy to set up. It's as easy as just pulling in some dependency and then using some JUnit test rule, and that's it pretty much. Paparazzi is also like pretty fast and cheap in the way that you don't need a special like CI/CD environment such as like Firebase Test Lab to set it up. The caveat though is that the rendering environment is actually different from that of an emulator or device. It relies on this library that's used to show UI previews on Android Studio. And like we unfortunately found that there's some parts of our UI code that just doesn't render correctly using this. So on the other hand, we have Shot, which runs on a device and emulator. So it's really, like the rendering is as close to like reality as possible. But on the other hand, they're like more difficult to set up and are more costly. Like aside from your normal CI/CD runner, you need this kind of device farm where you run all these tests on. And more importantly, these test cases also take longer time to run. So we found about like a 10x difference when we were looking at these frameworks about a year ago. Since the setup is more complicated, there's also a bit more room for instability. So even though we saw some caveats with paparazzi when trying it out, we still chose it because of the speed and reliability aspects, because we expect that to be important at the scale we expected. So for the second part of our problem, like providing this report of visual differences, we considered two different solutions. First of all, these screenshot testing frameworks usually come with some sort of built-in reporting tool. Like the upside here is that like no additional frameworks are needed, and we know that it's kind of supposed to work well with how the screenshot testing framework is set up. The second option we considered is some external diffing specific tool that we already used in our like iOS pipeline. So it essentially just works by comparing two directories of screenshots, like screenshot directory A and B, and we kind of get a report of, oh, which images were new in screenshot directory B, which changed, which were removed. So yeah, but these tools, they don't just differ like in the representation of visual differences, but also most importantly, where they store screenshots that we compare our current state to. Like remember that when we create a PR to merge into master, we want to compare the visual result of our code, including our changes, with how it rendered before it changes. So these screenshots that contain the state of the UI before our changes, they're typically stored somewhere and can then be used to compare to without having to rerun this old code. So to store these old screenshots, there's really two options exists. First of all, is we can just store them in Git. The workflow here would be that when you change your code, you rerun your screenshot tests, and then commit the screenshot files that were generated using your code. This is the workflow that's typically used with paparazzi and shot. The second option is to store the screenshot externally, for example, in some GCS bucket or in another cloud provider's disk, where you'd probably have like one directory per Git revision, something like that. Both of these solutions are possible, but we actually thought we might run into problems with the first approach. To illustrate that, you can think about the case where you have two PRs touching the same screenshot files. You merge one PR, and then you'll have to rebase the second PR on top since you got some merge conflicts. That's pretty impractical if you want to support large-scale visual changes. For example, if you have really good visual regression testing coverage of your features, but you slightly change the visual appearance of your design systems button, there'll be a lot of potential merge conflicts if your company is big enough that people merge all sorts of changes in parallel. So because of that, we chose to store screenshots externally. So with that, we also chose the diffing framework to be reg-suit. When storing screenshots externally, we also need to understand that which revision we actually want to compare to our current state to. So we don't want to compare against the screenshots generated using the code at the latest revision of our master branch, since like on master, all sorts of changes are merged all the time, so the UI already moved along as well. Instead, we want to compare the visual result of our code to the commit that our branch is based on. So yeah, like this base commit. So to summarize our choices, we decided to use paparazzi to generate screenshots from our test cases because like, we expect it to scale better when we have a lot of test cases. And then we also want to use reg-suit to generate a report of visual changes. And with that, we also decided to store screenshots at some revision of master in our GCS bucket. So let's look at how this can be implemented as a CI/CD pipeline. So the CI/CD workflow will essentially just consist of three parts. First of all, in order to generate the screenshots, we'll just run this like record paparazzi debug task. This will essentially generate screenshots in each module that has screenshot tests. So they'll be kind of located under source test snapshots images, I think. Then we'll have to copy the screenshots of each of these modules into a separate directory. So on the slides, I kind of provide the simplest way to do that, to essentially just copy them into a flat hierarchy. I think in reality, it's probably better to like group them, so it's a bit easier to navigate later in the screenshot testing report. In our case, we create subdirectories for each module, then package, and then test suite, and then each test name is just the file name of the screenshot. And finally, we can then use reg-suit to compare this directory to the same directory a few Git revisions earlier. So reg-suit, I think, is written in JavaScript, so you can just install it via npm. And then this command given the third line here on the slides, it will actually do a lot of work for us. First, it will fetch the screenshots that we want to compare to from our storage. Then this command will generate this report of visual differences and then upload it back to storage so it can be accessed as a simple web page. Here we also set two more variables. First of all, we have this expected key. That's the Git revision we want to compare our screenshots to. So this is essentially the point where a branch got started. And then the actual key is like the current Git hash that will be used to as a key to store the report. You see, like we're using GitHub Actions, so I just kept the variables on there. We have there. So both of these variables will actually be read within the configuration file that we have to provide as well. So let's walk through this configuration file. First of all, we need to set this working directory. This is essentially the directory where all the work that reg-suit will do locally will happen. So this is where your report will be locally generated. You can even open that locally in your browser then. And then we have this actual dir, which is the location where the screenshots at the current revision are located. So essentially where we copied all of our screenshots into 2 slides earlier. Finally, on top of that, there's also a few plugins we want to configure. The first one, these keygen plugins, they essentially decide under which key should we store our current report in the cloud. So in this case, we use a simple plugin because we just provide the keys manually here. These are the variables that we set earlier on the command line. There's a more automated approach as well. There's a different plugin that you can use, but we had some performance issues with that when using that. It would take a couple of minutes to generate these keys. So now we're just using the manual version, which is super fast. So next we configure this GCS bucket. This is where we store all of our reports. There's a couple of options of plugins as well, so you can use whichever provider you want to use in your company. And then we configure a plugin to notify our pull request that this report has been generated. First of all, this reg-suit comes with a GitHub app, and you need to register your repository there. So after that, you'll get this client ID, which you can pass in here. We also set this set commit status to false. It's set to true by default, which will essentially fail your pre-merge task. So there's kind of an additional step needed to merge changes when visual changes were detected. So since we just want to kind of acknowledge UI changes as part of our normal review process, we think that just kind of approving the PR is fine enough. So we set it to false. And finally, the last one is this one called short description. So if we don't set this, if this is set to false, which is the default, the report will essentially have one small icon per screenshot. So if you have a lot of screenshots in your report, you will get this massive comment. So instead, this short description will just post a summary. So then this configuration file, we just check it into our Git repository, and that's it. Then it's already there when we run the pipeline. And that's pretty much it. We're kind of done implementing this CI/CD. Exactly. So you should really be good to go once you implement that on your own tooling. So let's look at how we can use these screenshot tests then. First, let's see how we can write a suite of tests. So paparazzi, it comes with a JUnit rule. So screenshot tests are just written as simple JUnit test cases. In our case, though, we create a small wrapping rule. Essentially, this paparazzi comes with this JUnit rule, and you need to set all sorts of device properties on there. So we essentially want to make sure that we only have that all of our tests in the company share the same device properties. So we just create this wrapper where we can set all these things. Another thing we do is we actually, when you take a screenshot using this rule, you don't just take one screenshot, but two. One in light mode, one in dark mode. After that, the test cases are actually very simple. We just lay out our code in this composable lambda that we pass into the snapshot function. So yeah, that's it. In this case, we just test the design system component using some fake data. So what happens if I change the UI code of a component with existing screenshot tests and create a pull request with those changes? So I changed some existing component here to demonstrate. In this case, I think it's probably hard to see. I just added a little bit of padding on the left side, something like 2 pixels more. Yeah, probably very hard to spot, but something that can be easily overlooked in a PR review. So after the screenshot testing CI/CD task is finished, I'll get the following comment on my PR. Essentially, it shows a small summary of what visual changes were detected when using the tests. In this case, it was 18 screenshots were changed. So given that we have 2 screenshots per test case, we expect 9 test cases to change. On top of that, there's a link to an additional, more detailed report here. And when I click on it, I kind of get to the following page. So yeah, this might be a bit hard to see, but or to read. But on the left side, we have this menu that essentially shows a list of these test cases that we have. The directory structure here is kind of what I pointed out earlier, in this screenshots directory. Essentially, it's grouped by module, package, test suite name, and then you have all the test cases. On the right side, then you have the visual changes in each test case. So here, I'm not sure if you can see that this is red, essentially. This is some sort of diffing algorithm to diff between images of 2 revisions. When I then click on an item on the right side, you kind of navigate to a more detailed report where you can use multiple diffing methods to compare or make it easier to judge if this change was okay. The creator and reviewer of the pull request can then just go through this report and kind of judge if it looks okay, and then just approve and merge the pull request if it does. So, how far have we adopted this at DroidKaigi? So we finished the work on the CI/CD pipeline sometime in spring, and since then we've limited adoption to the design system module for now. We essentially wanted to do that to kind of gain more of an understanding of how we want to write tests. So even though we're still below 50% test coverage, in this one module we already got something like 700 screenshots. So a bit more than what I had expected before starting to work on this. The pre-merge task then takes about 8 minutes to run, but I mean, it depends a lot on your module structure, right? So then generating these 700 screenshots is very fast. It just takes about 30 seconds. So there's also some caveats though that I want to talk about that have hampered like further adoption a bit. The first one is this one. So we're using Jetpack Compose for all of our UI code, and when using Jetpack Compose, even though like this is like problematic, you might end up writing UI code that requires multiple compositions to render correctly. For example, like I put some rough code on the slides here to illustrate that. Like we have this component that lays out text at a certain font size, but like if the text overflows, like if there's an ellipsis or something like that, it will kind of try to use a smaller font size instead. Like you can see in this like on text layout on this callback, we check if there's a visual overflow, and then we like pick the next style in the list that I defined in the first line, which is ordered from large to small. So with that, it kind of scales dynamically depending on what text you put into the component. Unfortunately, cases like these are not supported by paparazzi yet. Like in this example case, the component will always render at the largest text size. So essentially, there's some components that just like don't render correctly using screenshot tests. We also haven't been able to like prioritize running the same test cases at multiple densities. This like display density is configured on the paparazzi rule, like JUnit rule, and there can only be one JUnit rule, paparazzi JUnit rule per test case. So we cannot instantiate multiple devices and then take screenshots with them. So from a first glance, it doesn't look super straightforward to achieve, but there's still some hope, I think. We haven't looked at it very deeply yet. And the third problem we faced was that paparazzi didn't work well with our remote build cache, or with our build cache in general. Essentially, there was a bug in the framework that kind of led to the chance that if you run this like record paparazzi debug task, no screenshots would actually be generated because it took some run from the cache that didn't include some flag that generates the screenshots. So given that we kind of had to disable the build cache on our CI/CD pipeline, which is pretty bad because essentially that meant we cannot scale it to many modules. Luckily though, this was fixed in the latest version. So yeah, if you adopt this, make sure you use some version from 1.3 or above. So essentially, even though we're using these screenshot tests, there's still some things that we're still missing and need to figure out. So the first one, and I just mentioned this, is essentially the adoption outside of our design system. That's the next step to take, I think. But also, kind of going back to the introduction to this talk, we were talking about having full branch coverage of all UI components, and this is kind of achievable, I think, or we already kind of achieved that in the design system, even though we have these other caveats. But the other thing that we really wanted to do is have some sort of integration test, but we haven't worked on that essentially so far. So like moving on to have tests for full screens, these type of integration tests will essentially require tests for each feature screen. So it would be the natural next step after just increasing adoption. So for that, I'm sure that there's still some challenges ahead. I think image loading, for example, and I think there's also a limit on like the size of the screenshot in paparazzi that we need to work around. So yeah, still some work to do on this. Exactly. That's it. Thank you for listening, and yeah, hope you enjoy this great conference.